Hello and welcome back to integrals. We will be working with the substitution method in this video. Last video was harder integrals. Now we're going to be doing things inside of parentheses, and it's basically a reverse chain rule. So I'm going to mix up the notations here to keep you guys on your heels. So f prime of x equals 3x squared, parentheses, sorry, 3x squared plus 2x plus 1, all to the fourth, times 6x plus 2. Okay, so to find this, we're going to take the integral of both sides. So f of x equals integral of 3x squared plus 2x plus 1 to the fourth, 6x plus 2 dx. And that's just notation. So for these, if you remember, we're going to let u equal the most complicated part, and that's going to be this right here. Okay, and remember in these we also need a du. So that derivative of 3x squared, that's 6x. Derivative of 2x is 2, plus 2 dx. So we have that. So that's du, that's u. So this is f of x equals integral of u to the fourth du, because we're just plugging things in. So that is just 1/5 u to the fifth, because the du goes away when you integrate, which equals 1/5 3x squared plus 2x plus 1 to the fifth plus c. Forgot to write that. I did forget to write that in the last video. I was killing myself for that afterwards, but I didn't want to have to re-record. So there's your answer. Right there. So let's do a harder one. Let's do dy over dx, switching up notations, equals cube root of 7x minus 5. And this is the Leibniz notation right here, and this is the Newtonian notation right there. So two guys discovered calculus. One of them wrote different than the other. Okay, so y is going to equal the integral of cube root of 7x minus 5 dx. With respect to x, is what that means. So, same process as before, let u equal 7x minus 5. And remember, that is like 7x minus 5 to the 1/3 power. So du equals just 7 dx, right? Well, looking up here, we basically have this to the 1/3 times dx. There's no 7 in there. So what we do, since we only have dx, we divide both sides by 7, and we get 1/7 du. And this will make sense in a second when I plug things back in. So u equals 7x minus 5. So this is u to the 1/3. We're plugging that in for this, times 1/7 du, because we're just plugging that in for dx, since there's no integer here. We have to divide that over, because there's only dx in this equation up here. So y equals the integral of u to the 1/3 times 1/7 du. Alright, remember, if we have the 1/7, we can float that out to the front. Y equals 1/7 integral u to the 1/3 du. Remember, the u goes away when we integrate. So y equals 1/7, okay, u to the 1/3, so that goes to u to the 4/3, because we're adding 1. So this is 3/4 u to the 4/3. So y equals 3/28. Remember to multiply bottoms and tops. It's weird how the smallest things can throw stuff off. Plus c. So 3/28, 7x minus 5 to the 4/3 plus c. And that's just another way that the substitution method can work for you. I think those are two examples that I'm going to do. The main thing is, if you don't have something that equals your derivative up here, it's to plug it in here and just divide it over so you have what you do have up here. So, yeah, leave a comment, leave a like if you appreciated it. It's good knowing where you guys are at on this, so thanks for watching.